Hello, everybody, and Merry Christmas. Um, we've been doing a lot of work in the insurance sector recently, and I wanted to share this template of how some insurance companies that are building stuff in Azure and Snowflake are building their data pipelines. I thought it was really, really interesting. These are built for massive scale, but also they're pretty pragmatic. So lots of stuff to do in terms of metadata. And yeah, let's dive right in. So what we have in front of us is just a really basic architecture diagram. But I say basic, it's more complicated than it needs to be. But the key bits are right in the middle here. So in terms of how data is going to move in this pipeline, we're going to use Azure Data Factory to land data from source and to land it in ADLS. After it's in ADLS, we're actually going to use Azure Synapse. And this is something which could obviously get phased out. Fabric have released notebooks. Databricks does exactly the same thing. But the reason we're using Synapse here is because often when we land data from the source, it doesn't always get landed in the format we need it to be in to land data into our warehouse. A good example would be how, like in Snowflake, if you want to push in data that has, maybe like a null field, you have to put in the word, I think it's null, or maybe the Pythonic value null. It has to be one but not the other. And then after that, we're going to show you how you can set up an external stage in Snowflake and then copy the data from ADLS into Snowflake. And then obviously after that, we're sort of all guns blazing and we can start using things like dbt or Snowflake tasks for the data vault modeling. And then at the very end, we've got activating the data in Power BI. So I'm going to walk you how you do this all the way through using Orchestra on top, but also using all of the component parts. So yeah, let's dive into ADF. Cool. So I'm here in Data Factory, and I've got a really, really simple pipeline. Now, a lot of people use Data Factory for anything from data movement to orchestration to monitoring. We're just going to use it for data movement. So think of ADF here as an ingestion tool, like a Fivetran. Now, what we're using here is the copy activity. So what you want to do is you want to define the source, which is where we're going to pull the data from, and then the sink, which is where we're going to land the data. So in this case, I can see I've got my, don't do that. I can see I've got my GCP data set. I don't know how to make that there again. Okay, thank God. And this is basically pulling data from a bunch of GCP tables. You can see that in order to create this, you have to create a data set, and that in turn has to be linked to like a linked service. And a linked service is basically the credential you need to connect to something. So in this case, I'm connecting via key file, so downloading like a JSON, but this could be anything. Now something else we have here is parameters. So what we're going to want to do when we load the data is we are going to want to parameterize the properties of the data set. And you could think of this as a way to create like a scalable data pipeline. Let's say you had a SQL Server with 100 databases and 100 tables in each. You only really need one pipeline to make that work because you're going to copy the data in the same way every time. But you are going to need to parameterize that pipeline. So what we have here is dynamic content, and this is just the ADF syntax, but it means that we're going to pass in these values when we trigger this pipeline so that we can trigger it many times at once. And yeah, it's pretty cool because if you do need to sort of define another sort of destination, like there are a ton. So that is the source. And then the sink is just Parquet. So we'll have a look at this. There we go. So again, you can see we've got the ADF loading, Google Analytics, file path, And again, what we would actually normally recommend here is even parameterizing this path with the name of the data set and then perhaps the date. So you can add dynamic content here as well. I'm not going to do that this time, but that's what we'd recommend you do. Cool. So I'm going to jump into Orchestra. I'm going to show you how you can trigger this in Orchestra. All right. So this is an Orchestra pipeline. And what I've done here is I've created an Azure Data Factory task to trigger the pipeline. You have to provide these fairly basic parameters, but the beauty here is really in the pipeline run parameters. So to set variables in ADF, you must pass a JSON that looks like this. And you can see here we've got two keys, table and database. Exactly the ones we were setting as dynamic content in the Azure Data Factory pipeline. Now what we've also got is this matrix syntax, and this is pretty jazzy. So in Orchestra, we have something we call the meta engine. And the meta engine is a way for you to parameterize your pipelines and then create multiple tasks at the same time. So in this case, because we're interested in using that ADF task multiple times to pull in many tables across many different databases, I've got these values in here. Now, something about Orchestra which is pretty unique and quite cool is that everything under the hood is just a configuration file. So you can see here that the matrix is actually sort of destructured into this nice YAML schema, which means that when you need to add another database or another table, it's just a question of adding 2 more rows into this file. Something which is quite cool, and this is what a lot of people we work with do, is they actually store those values in a database itself. And that's because when you are processing, thousands or tens of thousands of tables at once, it's not feasible to have a configuration file that is that long. So what you could do is you could have another step here, which is going to be called fetch config, where we're getting the value from the config table. And all you have to do with Orchestra is say set outputs here. And then when it comes to the matrix, you can go ahead and set the matrix as the previous values. So I'm going to go to fetch config, outputs, results, and you could just make this that. And that way you're going to get even more scalability. So for now, we're not going to do that. I'm not going to do this. I'm going to save. And I can run this. So I'm just going to run this task. And you'll see that instead of having a single data factory task, we've actually got several. You can see in this case, we've parameterized the pipeline. So this is running, events 202. What's this one? This is also 202. Maybe I've just put it in twice because I'm lazy. So yeah, we've got 725 there, 723. So they're all processing different bits of data. Cool. So that is the first step. Now I'm going to show you what it looks like in ADLS. Okay, so I realized that for some reason I had variables getting set in here, but actually what you need to do is set it via parameters. If you then need to use a variable, there's a set variable activity. So it's slightly different, just a small nuance, but all good. Anyway, if we head over to ADLS, you can see that we've now copied a bunch of Parquet files. And the automatic schema is quite nice. because I've got the name of the table, but the name of the table also includes the date. Often you're not going to have this, so I would highly recommend parameterizing the path. And if you're not going to parameterize the path, I would highly recommend parameterizing the folder structure. So you could have like Google Analytics slash analytics events slash 1912 2025. But yeah, this is ADLS. There's then now going to be a step where we clean it. So then it's going to push stuff into Google Analytics clean. So let me go into Synapse and show you what that looks like. Okay, so we are in everybody's favorite piece of software, which is Azure Synapse. You'll notice that it actually looks very similar to Azure Data Factory. For those of you that don't know, Data Factory is about 12 years old, 15 years old. And it actually had a reincarnation because they built everything again in Synapse. The problem was by doing it again in Synapse, they didn't actually have all of the functionality in the original Data Factory. So you can basically do the same thing in two places. Like I can't even find it to show you where it is. I would have thought it would be an integrate, but it's not there. So whatever. Anyway, what we have is a Spark notebook. And it's worth noting that the boot up times in Synapse are pretty slow. You have to provision clusters. You have to sort of get familiar with the Livy API to really become a pro at this. And I didn't do that. Now, this is actually quite a common use case of this step, which is to destructure some data. So for anybody that's worked with Google Analytics data before, you'll know that there's some heavily nested JSON in there. And it's kind of gross. Like you wouldn't want to just dump that into your data warehouse. So what I've got is I've got the table name and the database name. You set them as variables up here. And then if you trigger this via API, you get to override them. These get put into the path, which is just the path of the container in ADLS. So if you go to your Parquet file, there will be a sort of URL which you can take, which corresponds to this. I then used ChatGPT to generate some code to clean my data, which I was very happy about. And then we're just going to sort of drop that data down. And you can see now, after doing that, we've got this much nicer flattened view of our web data. So fairly simple, but the idea being that, as long as the data that you're landing is in like a sort of like common format, then you can sort of apply any logic you need to here. So this would be like a very good use case if you have, say, partitioned tables, because then you're going to need to process exactly the same data, whatever, like 8, 16, 32 times. The idea being this Spark notebook is like a modular component that we're going to trigger from Orchestra, which I'll show you now. Okay, so in the next step, we are triggering the notebook. So what I've done is I've added an Azure Synapse workbook or notebook node. And we can see that we've got the notebook name, we've got our connection, and then we're passing the parameters in here. In this case, I haven't put the matrix in, but you could. The limitation of Orchestra at the moment is that there's no way to apply the same matrix to multiple series of tasks. So you can do it if they kind of go down. So if I wanted to have another Data Factory task here, you could apply the matrix to both of these, but these are going to run concurrently. And what we actually want is to run it in a step. So that's not supported at the moment, but I really want it for this use case. It doesn't really matter because ultimately all you're going to do is you're going to add the matrix here, and then there'll be a little bit of latency in between these steps. But yeah, like this is basically how you trigger the Synapse notebook. And then obviously you get your clean data. And then at that point, we're going to be ready to move stuff into Snowflake. So I'll show you that next. Cool. So creating an external stage in Snowflake is kind of mad. And I'll tell you why. So the first thing you have to do is create a storage integration. You only need two inputs here, which are your tenant ID and the URL for the like container bucket, which you can get from Azure. If I run this, it says I don't have the right permissions, which is pretty classic. So let's be somebody else. Okay, and now it says we've created a storage integration. And this is scary because it's like, well, I've not given you any credentials. How have you done that? But what you can do is you can show your integrations this way. So we can see we've got this one here. And now we can create another stage. And a stage is essentially just another object in Snowflake corresponding to the data that you're pulling out. The way I see it is that like the stage is sort of like the bucket, and then the storage integration is almost like the connection you need to get data from the bucket. So if I go ahead and create that stage, you'll see we've created the stage. Now, you can actually list the files in that bucket, which is kind of mad. And this is the bit I wanted to show you. So what you have here is this fascinating little value called Azure consent URL. And if you click on that, you're going to go back to Snowflake. You're actually going to go to snowflake.com. But what it means is you can now pull data from the stage through that sort of like flow. So you can see the storage allowed is blob.core.windows.net/ADF loading. And then again, like if we take a look at what we called the stage in the first place, before I had it as ADLS Gen 2. Now I've got ADLS Gen 2 demo. So if I go ahead and list the files, this will now work, which is absolutely crazy to me. But anyway, that's basically how you hook up ADLS to Snowflake. So pretty simple. And then, yeah, you need to create a file format, which is essentially going to govern like the format of the data as it lands into the stage. And then the syntax for copying the data is kind of gross. Here I'm just renaming columns basically. But again, like this could all be parameterized, but I'm not going to do that. And now I'll show you how to do it in Orchestra. Cool. So the fun thing about the Snowflake bit is the Snowflake integration in Orchestra is really straightforward because everything is fundamentally a Snowflake query. So all I've done is I've copied what we had before, but you can see that URL now has matrix.tables in it. So if you did then need to load data from multiple places, you can just again apply that same matrix we had before and trigger all of these jobs. And again, it's nice because the pattern here is going to be the same. Something else you could do is, if you didn't want to explicitly set all of this in code, you could sort of nest it within something like a Snowflake task, which you then parameterize. So I can't remember the syntax exactly for adding a parameter, but it'd be something like execute task, kickoff task, and maybe you put the matrix in brackets. Can't remember exactly. But the cool thing here is that obviously you've then got all of your jobs in code. They're all parameterized. And if we take a look at what running that looks like, I can see if I've got the syntax right. Lovely. So yeah, multiple SQL queries firing. We've got our table in, but unfortunately the syntax is completely wrong. So yeah, I will add in the comments about how to do that. But that's basically it. Because after that, after you've executed your tasks, now you're in data modeling heaven. And this is where Orchestra really comes into its own. And this is what we see these large companies in the insurance sector doing, is having, I guess, quality steps that happen after the data's landed. So this isn't always using Orchestra, but having a sort of like matrix framework for defining quality tests is really helpful. So in this case, we have a DBT style test, which is getting all of the rows from a table where a particular column is null. So we're going to throw an error if we have any results. Pretty standard. But then after this, you would typically see people doing one of, should we say, three things. One is running DBT. So Orchestra provides a way for you to easily run DBT. We can also do things like fetch the Snowflake credits per query, which is pretty cool. Increasingly, we actually do see people running DBT core in Snowflake, but it's pretty hacky. But that would just be a question of running a Snowflake query. The other thing is people running their data models as series of tasks in Snowflake. So again, that's just going to be something that looks like this. And then finally, the other thing, which is very popular in this industry, is using a specific data modeling tool like Coalece. And under the hood, Coalece is also just code. It's also declarative. So it's pretty cool because you have all of your end-to-end orchestration controlled in a config file in Orchestra, but then Coalece also has those modeling guardrails. And again, you can do a similar piece of functionality here. I guess an important thing to note is that often you don't actually have all of these processes sitting within the same team or domain. So, it's rare to see people create this entire pipeline end to end. Now, I think it is a good fit if you have a couple of schedules, which again is quite common. So typically companies in the sector loading stuff every day, but probably also wanting to have an hourly schedule. Obviously, we should be doing better than that. Orchestra supports event-based workloads, so we can go as fast as you want. But that's typically what we see. And let's say you had, like an hourly and a daily pipeline. That would just be a question of having your daily pipeline like this, and then the hourly one is probably going to be a separate config file. So, basically exactly the same pipeline as this, but the cron schedule will be different. And then maybe the parameters that you're running through the matrix is going to be different. If you had a SQL job here to fetch the parameters, then it would be a case of changing your config query to be something like this. So yeah, Orchestra provides you a really nice way to basically extend this pattern across different schedules by doing sort of like minimal code changes. And obviously, if you then needed to have a 15-minute one, it's really easy because you can just clone a pipeline. Instead of this, what we'd probably see is another team having, basically just having their own pipeline that looks a little bit like this. So you have your DBT task, But instead of just running it on a schedule, which would be very flaky, you could do one of two things. So you could trigger this from another pipeline. Pretty simple. Or you could even have a sensor. And with a sensor, with multiple sensor checks, you could actually check to see if you have data from all of the tables you need. And I think this is quite nice when you have, many different sort of like team domains with marketing, finance, and so on, because not all of the models that you're building are all going to be codependent. So you could have something like select everything from, the finance tables, make this query as complex or as difficult as you need, and then run a sensor. And then again, the nice thing is that, if you expect the data to arrive in between 8 o'clock and 9 o'clock, so this sensor is going to run for 60 minutes in between 8 and 9, you'll get an alert at 9 o'clock if you don't have it. And then you know something's up. And then, of course, at the very end, just to sort of round this all off, we have our Power BI activation. But this doesn't have to be Power BI. It could be a Python task, which is taking some of that clean data and pushing it back into your CRM. It could be an agentic workflow in Orchestra. It could be another pipeline. The point is that within Orchestra, you've got like a really, really easy way to build these pipelines. When it comes to Lineage, Orchestra's going to get all of this underlying metadata. It's going to give you a really easy way to restart stuff from the point of failure. And then, the big thing in this industry as well is analytics and audit. So the last thing you want at the end of the year is for your CEO to come to you and say, where's all this data? Like, one of the regulators needs, a log that shows that everything we said ran, and all the data we gave them was true. Today, you're going to be pulling logs from multiple places in Azure and perhaps even Snowflake, which is very painful and time-consuming. Orchestra gathers all of this metadata automatically. We even have an AI agent that can drop this data just like into your data warehouse. So yeah, this is a quick summary, I guess, of how people are building data pipelines on Azure and Snowflake in insurance, but also in other sectors. And this is how we put Orchestra on top. So yeah, hopefully you can see that it's a lot easier than having many layers of nesting in Data Factory. And very excited to get the meta engine extending to horizontal tasks. But that's all for now. We'll put in a bunch of links in the comments. But yeah, please drop a like and subscribe if this was interesting.